in example 1, it's asking us to calculate the discriminant for some different functions, and then also to determine the nature of the root for each of the following equations. So we're going to start off and look at A. A is 5x squared plus 4x plus 6 equals 0. So this is a quadratic equation in standard form. So in order to determine our discriminant, it needs to look like this. We must have some number times x squared. We don't need any number times x or any number times or any constant. We don't need those, but we do need, on the other side of the equation, it equals 0. So those two things are required, a number times x squared and that entire expression equal to 0. All the extra stuff affects the discriminant, but it is not necessary to calculate one. So we need to look and identify what our parameters are. So we say whatever is attached to x squared, we call that A. Whatever is attached to x, we call B. And whatever is attached to itself, or whatever is the constant, is known as C. Well, we use these with this following formula. Our discriminant is b squared minus 4ac. So what we need to do is we need to square the b term, which is positive 4. So we do positive 4 squared. We subtract away 4 times a, which is 5. And c is 6. And we need to evaluate this. Well, 4 squared is 16. 4 times 5 is 20. 20 times 6 is 120. So right here, what we have is 16 minus 120, which should be negative 104. So right now, we have a discriminant that is negative. Now, a negative discriminant means that we are going to have two imaginary answers or non-real answers. So these are non-real solutions. And there are two of them. Now b is x squared equals 8 times x minus 2. Now this one is different from a in that it is not set up in the general form for a quadratic. What we need to do is we need to make this equation look like a. We need to simplify and we need to move everything over to one side and have it equal 0. That is required in order to go and calculate what the discriminant is. So our first step is we need to break this apart. We need to distribute that 8. So it's important that we follow our correct properties of math. So the 8 goes not only to the x but also to the minus 2. So we're going to get, this is 8x, and 8 times negative 2 makes negative 16, and that, again, is equal to x squared. So now what we need to do is we now need to get everything on one side, and we need to get 0 on the other. There's multiple ways that you can do this. We can take the x squared and subtract it over, or we can subtract the 8x and the negative 16 to the other side. I like to keep my x squared term positive if I can, so I'm going to move this over, but you don't have to. So I'm going to get x squared. We're subtracting away the 8x minus 16. That's what we're doing. Well, in doing so, basically, when we move it from one side to the other, we switch the sign if it's just a single term. When we move one term from one side to the other, we just switch whatever the sign is. But what we are doing more generally is we are subtracting that entire side over. So that's why I wrote it this way. But what you can see is the 8x becomes, when we distribute, the 8x becomes a negative 8x, and the negative 16 becomes a positive. Now we can calculate our discriminant. We have our a, we have our b, and we have our c. So when we do b squared minus 4ac, we are going to get negative 8 squared minus 4 times a, which in this case, it doesn't look like there's a coefficient there, but it's a 1. We never express that in algebra. If you just see a single term with no coefficient, it's assumed to be 1, because 1 times anything is just itself. And then c is 16. Well, negative 8 squared, this is 64. Anything squared is going to be positive unless it's an imaginary number. So that is 64. It's not negative 64. It's negative 8 times negative 8. So make sure that you don't fall into that trap. And we got 4 times 1 is 4. 4 times 16 is 64. And we are left with 0. Well, a discriminant of 0, what that means is that we're going to have one real solution. And because it's a quadratic, that is actually, it's kind of like, it is a double root, we call that. It's going to be the same, there will be two answers, but they'll both be the same. So in a sense, it's just one real solution, but it is a double root, and we'll explain kind of what that means later. Now our last problem here is 2x minus 1 times x plus 3 equals 4. So, like the previous example, we are not in general form. So what we need to do here is we need to distribute, simplify this problem, and then convert it into the general form. So when we take a look at this, two binomials that are being multiplied by each other. There's a process in algebra that most people know as FOIL, which does this for us. It's very important that we don't skip any steps here, because we want to, in order to get the correct answer, we have to do the algebra portion right. So FOIL, if you guys remember, stands for first, out, in, and last. And so what we need to do here is we do our first terms, which is going to be 2x times x. 2x times x makes 2x squared. Right? The 2 remains, the x times the x stacks to make 2x squared. Then we do outside. So that's the outsides of here, which is going to be 3 times 2x, which makes 6x, a positive 6x. We then do the inside, which is negative 1 times x, which makes a negative x. We don't need to write the 1. If you do, that's okay, but we'll try to avoid that if you can. And then negative 1 times positive 3, which this now is our last terms. Negative 1 times 3 makes negative 3. And again, that still equals 4. So we're not quite done. We have to do some simplification here. We still have our 2x squared. The 6x and the negative x are going to combine to make a positive 5x. And then our, and then the negative 3 here, we need to combine that with this 4. So what we're doing is we're going to take this 4 and subtract it over. So we're going to subtract this over. It becomes a negative 7 now, and that is going to equal 0. Now we have it in a form that we can work with. So what we're going to do, we have our a, we have our b, and we have our c. So remember, b squared minus 4ac. We're going to have 5 squared. Okay, sorry. We have our b squared minus a 4 times a, which is 2, times c, which is negative 7. So we get 25 minus, this is going to be 8 times negative 7 is going to be a negative 56, which that is the same thing as adding 56 to this. And so that is going to be 81 as our answer. Well, this is a positive number. This is a positive discriminant. What that is going to mean is that we're going to have 2 unique real answers. So we're going to have 2 unique real solutions. So the discriminant is pretty easy to calculate. It's going to tell us what our answers are going to look like, which is really, really helpful. Using discriminants is a part of analyzing functions to figure out what's going on with them. It's not something that you have to calculate all the time, but knowing how to do it and knowing what it tells you can really save you some time and help you have a better understanding of these problems.